Hello students, myself Pankaj Kumar. Welcome to my YouTube channel Classmate Academy, and today I discuss about projection of point.
First, let us see what is projection. Consider an object placed in front of a source light. When the light is turned on, the rays project the outer surface of the object in front of the screen. The object appeared on the screen is a projection of the original object. Here, the object projected is larger than the original object. But here we will learn about orthographic projections. For orthographic projection, we draw straight lines from the outer edges of the object, which is always perpendicular to the screen, so that we get the exact size of the object. This is called as orthographic projection. Now we'll see a reference frame. Any object in space should have a reference from where it can be measured so that we know the exact location of the object. For that, we intersect two planes, that is vertical plane and horizontal plane. Horizontal plane is also called as HP and vertical plane is also called as VP or FRP, frontal reference plane. And the intersecting line of two planes is called reference line, that is XY. From this reference plane, we get first, second, third, and fourth quadrants. The object can be placed in any one of these four quadrants. The term above and below is always with respect to the horizontal plane HP, and term in front and behind is always with respect to the vertical plane.
Seriously, pay attention. This is important.
Now let us place an object in first quadrant. The third plane shown here is the profile plane PP or auxiliary vertical plane AVP. The object is placed between the observer and vertical plane. When the observer sees the object from the front, its front part is projected in the VP and the projected image is known as front view, FV. Similarly, when the observer sees from the top, its image is projected in HP and the image is known as top view, TV. And when seen from the left hand side, the image projected on profile plane is known as left hand side view, LHS. When the object is in first quadrant, the actual pattern of planes and views is shown. This is known as first angle method of projections and is represented as shown. Note, in industries, the term front view is termed as elevation and top view is termed as plan. Now let us place the object in the third quadrant. Here, plane is between object and the observer. Now when observer sees the object from front, top and side, we get the respective projections on vertical planes as front view, on horizontal plane as top view, and on profile plane as left hand side view. When the object is in the third quadrant, the actual pattern of planes and views is shown. This is also known as third angle method of projections and it is represented as shown. Note, according to Indian standards, we will be using only first angle method of projection. Now let us understand the difference between the first angle method of projection and the third angle method of projection. In first angle, elevation of front view is above XY line, whereas in third angle it is below XY line. Plan or top view is below XY line, whereas in third angle it is above XY line. Left hand side view is at right side of front view, whereas in third angle it is at the left side of front view. Right hand side view is at the left side of front view, whereas in third angle it is at the right side of front view. Let us understand the term projection of a point. A point may be situated in space in any of the 4 quadrants. Consider point A is situated in first quadrant. The position is obtained by extending their projectors onto the planes. Now opening the horizontal plane or rotating the plane in clockwise direction, we get the following result. Note, following notations should be followed while naming different views in orthographic projection. Now let us consider different cases of a point and understand the term above and below for HP and in front and behind for VP. Consider point A. It is given that A is at 10 mm above HP and 30 mm in front of VP. Taking line XY as reference line, as the term above refers to HP and in front refers to VP, draw a 10 mm line above HP and 30 mm line in front of VP. This is basic representation of the given question. Now project these points perpendicular to the plane, and the intersection of the projectors gives the location of point A in space. Considering another point B which is 40 mm below HP and 30 mm behind VP, similarly, understanding the term below for HP and behind for VP, draw a line 40 mm below HP and 30 mm behind VP. Now project these points perpendicular to the plane, and the intersection of the projectors gives the location of point B in space. This is the basic representation of the given question. Similarly, we can find for point C, which is 30 mm above HP and 30 mm behind VP, for point D, which is 40 mm below HP and 20 mm in front of VP, for point E, which is 60 mm above HP and on VP, for point F, which is 50 mm in front of VP and on HP, and point G is on both HP and VP. The representation of the following points with reference line XY is shown. The table shown represents the location of point in front view, top view, and which quadrant does it lie.